So in the previous video, we actually discussed with you a over s plus a, correct? And that the order of the pole is actually one order higher than the zeros. Alright, and we actually share with you how do we settle this matter. Now what if we have a same order? Okay, with same order, alright, by the definition, so this is the definitions: number of poles minus number of zeros minus number of delay is equals to number of zeros required. Okay, so therefore the degree of the poles, I should say the number of degree, alright, okay, so number of degree of the poles is actually 1 because the highest is x to the power of 1, right? Number of degree of the zeros is actually equals to 1 because the power over here is also to the power of 1, minus away number of delay. Over here we have no delay, so therefore the number of zeros required is actually equals to 0. Alright, so by definition, so this is what we do: s minus minus a, s minus minus b. Alright, so minus minus b will give you s plus b back. Alright, if you don't know anything about what we are doing right now, you can just watch back these videos. Alright, these are the definitions of what you need to understand. Okay, meanwhile, I have something to add on in between them. You also need to watch because I haven't done the video yet. So I'll just add it in between your l9v2 and l9v3 fighting. But anyway, I'll just carry on with this. So if you don't understand this, you just watch back the video. Otherwise, let's continue. So you know that s is equals to z, so I'll just sub in as z. And my minus a I can rewrite as e minus at in the z domain. Alright? Same thing, this s is equals to z, and minus b I just write as e minus bt. Alright? And I have a multiple of k is equals to your h of s. H of z. Alright? And then now I'm gonna evaluate the k. So to find k, alright, I will set s is equals to 0, z is equals to 1. Alright, I explained to you already, so I don't want to explain to you again. This is the standard way to find k. While your h of z now, I just sub in as the magnitude of your s. Okay, so what I do is to sub in s is equals to 0. So I will have equals to a over b. Alright, then I sub in my z as equals to 1. Alright, so I have z is equals to 1, equals to 1. Alright, so let me rearrange. Alright, so therefore the next step is, my purpose is to find k, correct? And therefore I'll just simply rearrange. I bring this denominator, I bring it up, and then the numerator I bring it down. Alright, it's just simply the rearrangement of your math. Alright, just bring it down. Okay, so therefore your k is equals to this thing. Okay, and then next I take this whole transfer function, I paste it over here, then I sub in my k, alright, as this thing over here. Okay, so therefore this is the full form of your transfer function in the z domain. Okay, so this whole thing is your k. Okay, therefore let's make things more interesting. Okay, what if we have a delay? Alright, if we have a delay, then what we can do is actually to introduce like 1. Okay, so 1 minus 1 minus 1, we will have minus 1. Okay, so if the number of zeros is required is actually negative 1 in this case, this means that you're gonna add in a delay. Okay, you can add in a delay over to your s plus a and s plus b. Okay, so I'm gonna rearrange everything. Alright, I'll just cancel off. Alright, so over here I'll add in a delay 1 over s plus 0. So 1 over s plus 0 is actually 1 over s lah. Okay, so 1 over s is actually a delay. Okay, but anyway, so in such of the case, this is the number of poles and the number of zeros aren't the same anymore. Alright, over here this is negative 1. Alright, now we got a new set of calculation that we need to set up. Okay, so what I mean is, over here with this is a new form of a transfer function. This is with a delay. So with a delay, we need to also increase. We need to actually have one more zeros. Alright, because the number of degree of the pole is now 2, right? 1 and 2. Alright, so 2 minus number of degree of the 0 is 1, minus number of delay, there is no delay now, so it's 0. Okay, so 2 minus 1 is actually equals to 1. So therefore I have a number of 0 as s plus infinity. Okay, so you may wonder why here number of delay is 0. Alright, it's because this is the second round. Alright, the first round is only this. Alright, it tells the system tells that you have a s plus a, s plus b, but I got a delay. So when you have a delay, you're gonna have you need to set up a new transfer function, which is 1 over s. So when you have a new transfer function, then you need to recalculate your stuff. So over here, you aren't having any number of delay anymore, right? Because you already add in the delay inside this new transfer function. Okay, so therefore we're gonna recalculate everything, and we're gonna do what we used to do. Alright, so therefore let's just continue, and just to keep in mind, I may be wrong in a way that by adding the delay means it's 1 over s, but I would feel that this should be correct. Alright, and therefore this is something that you may need to understand also. So therefore I think you have okay, so therefore let's continue lah. Okay, because in a general occasion, if you already know how things works already, but anyway, of this case, you'll still need to evaluate this type of equation. Alright, if like s plus a, s plus b, then multiply by s, this type of equation may still come out to your exams. So you still need to know how to evaluate this. This is why what we are doing now is still related to what you're gonna do. So instead of 1 over s, I write it as 1 over s plus 0, because it is easier for us to evaluate the system. Okay, so let us just continue. So s plus a, I just write as s minus a, and then s plus b, I'll just write as s minus b, multiply by s plus infinity, I'll just write as s minus infinity over s minus 0. Okay, so I think that you are pretty clear now. So next, I'll just subplot my s is equals to z. Alright, minus a is actually e minus at. Alright, s is equals to z, and then minus b is actually e minus bt, multiply by s is equals to z now, and then minus infinity t. Alright, and then s is equals to z minus e to the negative 0 t. Alright, over here we know that e minus infinity t is equals to negative 1. Alright, we actually showed you in the previous few videos. I think l9v7. If you forget, then you just watch that video. Alright, it's with regards to the position of the s domain and the z domain lah. I'll not go into details, but just stick it lah. So therefore, this side over here I need to change. So I'll just bring this thing. I'll just bring it down. I will not change anything. Well, I'll change where am I? Multiply by z. This one is minus 1. So I have minus 1 over z minus e to the power of 0 is what? E minus 0 is actually 0 still, right? So e to the power of 0 is 1. Correct? E to the power of 0 is equals to 1. You just type inside calculator. Okay? So I have this form. Okay? While this form, if I were to bracket everything, where am I? Yeah. Bracket everything, k is equals to h of z. Okay? So the whole thing is your transfer function, and therefore now we're going to evaluate the k again. Alright? So take it as just a practice. The more you do, the more you realize that actually it's pretty straightforward already. Okay? So for the h of z part, alright, we know that we need to take in the functions, our initial functions, which is s plus a over s plus b multiplied by 1 over s. Alright, so just take this will do. Okay? So you may wonder, just now we started off with s plus a, s plus b, and then we say that there's one delay, so we add in this one. So do we ignore that? No, we don't ignore, we need to include it inside. Alright, so this is now our original function. Okay? Because we are already adding in the delay. Okay, so I hope that you are pretty somewhat clear. Alright, and this is only applicable only when this is 2 to the power of 1 and this 2 to the power of 1, or in other words, when the order of the poles is equal to the order of 0, Then if you have a delay, then you add in 1 over s. Alright, then we start out with all these things already. Alright, so please take note, if happen that you have a difference in order, for example s plus a and s plus a, if this is higher than this, then you just do the simple s plus infinity and then you evaluate. If it's, for example, our initial start, if you still remember, is s plus a, s plus b, they are the same order, alright? And if you were to introduce one delay, you actually introduce 1 over s, okay? So therefore, this is something that you need to understand. And nonetheless, nonetheless, I may be wrong in this perception, but still, this is still your original function. Alright, this is, if the s plus a, s plus b, if one delay is times 1 over s, if it's not a good example to deal with, then just take it as evaluating this thing straight away. Alright, so you just take it as a question, because this type of question will still come out in the exam. Alright, so to speak. Yeah, I don't know. But never mind. So our purpose now is still finding the k. So just not to be confused, or that you just take the original transfer function from our initial start, alright, which is s plus a and s plus b over 1 times 1 over s will do. Okay, so ignore what I say for the delay part for the s plus a over s plus b, and then if I want in the delay, I'll times 1 over s, because I think that this may actually confuse you. So yeah, but any of the case, if you want to find k, alright, just sub in the original function. Okay, so no matter when you find k, your s is equals to 0, your z is equals to 1, standard. Alright, so when I sub in my s is equals to 0, this is 0, this is 0, and then a over b multiplied by 1 over 0 is actually infinity. Okay, so this thing over here is actually infinity. Is it? Okay, never mind. I'll leave it. Okay, I'll leave the answer as this. Alright, s plus a over s plus b s, right? So if this is 0, this is 0, alright, this is 0, alright, I'll have a over, alright, 0 plus b is b, alright, multiplied by 0. I'll just leave it as this form. Okay, so let's just leave it at this form. Okay, later on we'll do something with it. Alright, I don't know why is it something like this, but let's just take it first. Okay, and then over here, alright, the z is equals to 1. Alright, so I'll just simply remove all the z. So all the z's over here, I'll change to 1. Okay, over here this is the z, I'll also change it to 1. Over here, so therefore I have 1, 1, 1, 1. Okay, so all the z's I change it equals to 1. Alright, so over here this one will become what? This one will becomes 2. Why? 1 minus 1 is 2. So 1 minus 1 is actually 0 also. Right, so okay, so therefore I have this thing over here. Okay, so if you find it familiar, alright, this 2 times this thing over here is somewhat equals to your a, while this thing over here is somewhat equals to your b, or this 0 over here is equals to that 0 over here. So we somewhat ignore the 0. I don't know what's the reason, but this is from another lecture place, alright, which is that they actually have this thing. Alright, this is what we are going to derive now, because they actually ignore the 0, because they somewhat seems like they're equals to each other. Okay, so I'll just let it just show you in terms of that. So I remove all the zeros because I have no idea why they actually ignore the 0 for some reason. Okay, so now we have this thing over here. Okay, then I can evaluate already so I'll just bring the 2 down first. Alright, so I will have this 2, I'll just bring it down to the denominator over at this side. Alright, over at this side, and then equals to this thing. Alright, and then now I'm going to bring this up to the top, I'm going to bring this down to the bottom. Okay, so this is something that you may need to also understand. It's like a cheat code, I think. So over here now this is this. Alright, if you were to compare, okay, no need to compare because I didn't paste it. But anyway, this is the thing. So if I were to compare to the book, well, did I repeat myself? But anyway, I just let me repeat because I don't know whether did I say. So over at this side, which is what we have derived, is this one. But compared to the book, that we have additional KC. Alright, and therefore you may wonder why is the KC. Alright, it's because if you still remember just now at the very first part, where we say that we cancel off the 0 because we don't know why they cancel off the 0 each other and then they rearrange. Now I finally know. It's because we set s as equals to 0, z is equals to 1. Okay? But however, if you set s is equals to something else, alright, because when s is equals to 0, because if you still remember back all the way, alright, this thing over here is 1. Alright, if s is equals to 0, z is equals to 1. Where this one over here is actually, if you still remember, this is s plus a over s plus bs. Right? So if s is not 0, which is some values, alright, then you will have some values over here and you have some values over here already. Alright, so this thing will not become 1, this thing will become maybe like 0.8, things like that. Alright, so therefore there will be, if you were to rearrange, for example, give me a while, let me think. Okay, so for example, if my s, alright, if my s is equals to some values, alright, if my s is equals to maybe 2, then my z will be equals to some constant, I just write as c. Okay, so over here, in this case, I just write it down my transfer function. And you may wonder what am I doing now. I'm actually trying to prove to you that this kc will still exist. Because just now we say that we ignore the 0, right? So I'm going to explain to you why to a certain extent we can ignore the 0. Because of this particular case that I'm going to explain to you. Alright, because your s plus a over s plus b s. So if your s is equals to 2, you'll have 2 plus a over 2 plus b. Okay? So therefore over here, I can just sub in as, instead of this, I'll have 4 plus 2b, so to speak. Alright? And this z is equals to c, I'll have some values. Alright? I'll change it to some c values. You see? So I have c all over here. Okay? And then, actually I shouldn't have multiplied it in, damn it. Over here I should just leave it as 2s plus b. Okay, yeah. So over here now, then we can now rearrange, right? So this c minus 1, I'll just bring it up over here. This c, okay, this whole denominator, because they are multiplied each other. So this whole denominator, I'll bring it up to the top. Okay. You may wonder what am I doing. Just pause. You just wait a while first. I'll just continue to paste these things. Alright. So I'll just paste this out over here. Okay. And then I'll just make this division over here. Okay. So I have rearranged. I bring this all the way up to this side. I think you get what I mean. I'll just simply rearranging stuff also. So this part over here, I'll just rearrange, and therefore, where am I? This thing over here is equals to k. Yeah, equals to k. Because I'm simply shifting this thing up to this, and I shift this thing down to here. So this is what I have. Okay, in order to find k. Okay. Next, I'm gonna compare it with what we have derived just now. Alright, so I have these things over here. Alright, now if I were to rearrange, I bring this thing, I just bring it out to this portion over here. Okay, although it's not pretty clear, but at least you get to see that this particular portion divided by 2 is your kc for a bit of the reason, and then this over here is some form of your, maybe I should write this as 2. Okay, wait this is 2. Okay, yeah, so therefore this part over here is something like this part. Okay, because now we have, if you still remember, now our s is equals to 2. Previously, for this equation, s is equals to 0, z equals to 1. Alright, so if s has a value, then you see there is some constants coming out already. Alright, so therefore we want to also include this particular constants to our system. Okay, and therefore we want the kc to be there. Alright, so I hope that this is at least give you a certain understanding. Well, actually from here you can see this part is very clearly the same as this part. Just the c is equals to something. This one is c equals to 1 for this case, because our z is equals to c. Previously was z is equals to 1. Alright, so I hope that this is pretty clear. And why do we actually ignore the 0 at first? Alright, our calculation, if you still remember, I think you get what I mean already lah. Okay, so I hope that at least you get a full view of everything, although I think that this video isn't very well explained, and but at least you get to know this little stuff lah. Okay, so see you soon.